Now we're going to look at the solving these trig equations. So I'm walking you through this slideshow presentation we did in class. So let's see if we can make some sense of all this. So here's a first equation. Solve sine of x equals 1/2. Okay, so sine of x and 1/2 should be familiar stops on the unit circle at pi over 6 and 5 pi over 6. However, okay, that's not the only places, that's not the only solutions to this equation. Okay, so if we look at the graph of the sine of x and see where the horizontal line y equals 1/2 intersects it, we see here, this is the pi over 6 value, this is the 5 pi over 6, but again, we see it's going to hit those places the next cycle down the line and the previous cycle back here. So these are not the only solutions. These are 2 solutions per cycle. Okay, to account for all the subsequent solutions, we have to account for the next cycle, which is adding 2 pi to this. So then, therefore, it is proper to say that the solutions to this equation are pi over 6 plus 2 pi k, 5 pi over 6 plus 2 pi k. That's accounting for all solutions. Okay, let's take a look at a couple more. Cosine of x equaling root 3 over 2, that should be a familiar value for you. Again, that should be a pi over 6 value. Okay, but cosine is positive in the first and the fourth quadrant, so it's pi over 6, 11 pi over 6. But then each of those with a plus 2 pi k value added. Tangent equals 1. The unique thing about tangent, as we'll see later, is that it has a period of pi, not 2 pi. Therefore, tangent equaling 1 has solutions at pi over 4 plus all cycles down the line, so plus pi k, not 2 pi k. Cosine equaling root 2 over 2, that's a 45-degree or pi over 4 reference. But we know that that's positive cosine in the first and the fourth quadrant. So it's the pi over 4 and the negative pi over 4, or if we want 7 pi over 4, each with the plus 2 pi k value added. Sine equaling negative root 3 over 2. That should be recognized as a pi over 3 reference, but sine is negative in the second and third quadrant, rather the third and fourth quadrant, so that's 4 pi over 3 and 5 pi over 3 plus 2 pi k to each of those. Tangent of x equaling negative root 3, that's a pi over 3 value where the tangent is negative. References, which is in the second quadrant, which is 2 pi over 3, but I'm going to say it this way, negative pi over 3 plus pi k. Adding that pi k would give you that first stop at 2 pi over 3, okay? If you put 2 pi over 3 plus pi k, that's equally as valid, okay? And what I have here is a note that I'm listing the first solution closest to the origin. Once we take a look at the graphs, we'll get a better understanding of that. Okay, let's take a look at this. Sine of x equaling 0. Well, that's the x-intercepts. Sine crosses the axes beginning, middle, end of its cycle, 0, pi, and 2 pi, which really can be condensed as all multiples of pi. So we say pi k. We're calling it k, it's just an integer. Cosine x equaling 1, okay, is to imply the beginning and ending of the cycle, 0 and 2 pi. Better off just saying 2 pi k. Cosecant equaling 1. Cosecant is the 1 over sine, so that's how we'll view it, as 1 over sine equals 1, which is the same as the sine equaling 1, which is going to happen at pi over 2, okay, and then plus what should be here, 2 pi k, pi over 2 plus 2 pi k. Cosine equaling 2, that can never happen, okay, it's empty set. Secant equaling negative 2 is the same as saying 1 over cosine equaling negative 2, all right, which is the same as saying the cosine equaling negative 1/2, and that's a value of a pi over 3 value where the cosine is negative, okay, which is in the second and third quadrants, 2 pi over 3 plus 2 pi k, 4 pi over 3 plus 2 pi k. Some of these will be resolved. These are just one step removed from the previous problems. So if we just simply deal with dividing both sides by 2, we now have a more familiar equation. And again, these are the first hits. I got a little brevity here. It should just say x equals pi over 6 plus 2 pi k, 5 pi over 6 plus 2 pi k. Here, okay, divide by 2, and that is a 45 reference where the cosine is negative in the second and third quadrant. Again, each of these is with a 2 pi k. Sine squared equals 1/4 is the same as the sine equaling 1/2 plus or minus, and that is at all these stops, okay? And these could be condensed a little bit like by saying pi over 6 plus pi k, because that would give me the 7 pi over 6 here, 5 pi over 6 plus pi k, which would give me this one as well, okay? Over here, we are going to send 4 to the other side, divide both sides, cosine equaling 1/2 at all pi over 3 reference values, cosine equaling positive or negative pi over 2, and positive or negative 1/2 at all pi over 3 reference angles, which can be condensed into saying pi over 3 plus pi k. That would give you the next one here, 4 pi over 3, and 2 pi over 3 plus pi k, which would get you this guy, 5 pi over 3. Okay, we'll stop it there and look at some other examples in another video. Okay, there you go.